Hi, Braden. Starting with Euler's method. Um, it's basically a simple method to estimate uh, the value of a function of an ODE function given an initial value. So here we can see we've got an example. Let's say of a differential function f, and what the Euler's method basically does is it starts with your initial value, and then you add to it the slope at that point times the step. So in this case, the delta t to the next point. And that gives you the estimated value of the next point. A simple chart can be seen here for that. Now the Runge-Kutta is based on that, more or less. It starts similar to Euler, except for the slope is not the slope at one point. The slope is actually calculated 4 different times. So what you're generating essentially is an average slope. So simple equation is basically it's 1/6 the sum of k1 plus 2k2 plus 2k3 plus k4. Now, instead of trying to arduously draw this, I've got a picture here that I found, and basically kind of shows how you're summing up the various slopes. So you start at your initial point here, and then you calculate this slope once you've gotten to this midpoint, because you're not going all the way to t, the full delta t. So you go to a midpoint, and you calculate the slope again here. Then based on that, you adjust, create a new point here, based on applying that slope down here, and then replicate a new slope. And then finally, you apply that new slope to the fourth point, the one at delta t, generating a new slope at that point. And then all this gets summed up into an average slope. So kind of a graphical representation of what's going on numerically. Hope that helped. The difference between Euler and Runge-Kutta fourth order.